Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Arteris with Insaf Meliane. I'm going to talk today about accelerating IP reuse. Insaf, devices are becoming much more complicated. The market windows are shrinking. What's the problems that you're starting to encounter with using IP and reusing IP?
Yes, so we saw that with our customers, the designers are struggling, having more and more content to be integrated from different sources. They have the third-party IPs, they have the internal IPs, new or legacy, that they need to be integrated all together and to ensure that the interface of each IP will be compatible with the rest of the system. And also, we know that having this complexity, the size also of the SoCs becoming more and more large. The traditional solution that they are using with manual processes, manual scripting, this will lead to some misalignment, to errors actually, and so we will need more time to address these errors, fix them, so you will have a longer time to market to be able to have your product pushed out at the end.
This has been a problem with IP though from the start, right? What's different now?
The difference now is you will have more than 1,000 IB to be integrated in your SoC. So you need to find to put in place some automation to be able to shorten this integration time and at the same time ensure the quality of what will be generated at the end.
Let's take a closer look.
Sure.
Insaf, what are we looking at?
This is the flow actually that we are using to package the IP using our solution, Masilem packaging with the different steps. So we start first with importing the description of the IP. We can read directly the RTL description of the IP, whether it is in a Verilog or a system Verilog. Of course, we can read the legacy and older version of IP-XACT 2009 and 2014 and now 2022, and the description of the protocols. So the tool will generate automatically the IP-XACT 2022 description of these elements. So we'll have the description of the ports, description of the parameters. This will help to the configuration of the IP when it will be instantiated. The ports, if you have specific protocol that are used in this IP, we can actually map them into bus interfaces. The bus interfaces actually are very helpful because it will help you to make the integration much easier. We will have like 50x less connection. It will help also to have a reliable integration, because when we'll be connecting one target to one initiator, we will be with the IP-XACT standard to be sure that these two bus interfaces are compatible. So this will help also to detect error early in the process and not be a blocker later.
So you've got two major problems here, right? One is you have a lot more data that has to be moved these days than in the past, and it has to be moved faster than it did in the past. The second thing is you have a lot more complexity. You have potential physical effects that you have to contend with, and you really need to understand all that up front as you put this together, because you've got a lot more density in these designs.
Yes, actually, the benefits of the packaging of the IP is the more information you will put in this packaging, the better and the most benefits you will have at the end, because these information have been validated, so the integration will be reliable, and at the end you will have a better integration and better quality of your design. So on top of these elements that I described earlier with the parameters and the bus interface, we have also the description of the memory map. This will help to generate all the collateral needed, like a VC header, UVM-RAL that will be used for the verification. We have also the views which reference the file sets, and these are very helpful actually, because it will help you to have in one description of your IP the different usage that can be done with the different teams that are working on the same project. So we can have views like for the simulation that will help you to have all the files needed to run a specific simulation. You can have views for the emulation, for the synthesis, and all this is in one single source of truth specification that will help you at the end to have consistent data that could be used without any problem at the end.
And one of the big changes here is that in the past you were pretty much using block by block and integrating that kind of IP. But now you may be integrating entire subsystems into these complex packages, right?
Exactly. With IP-XACT, actually, there are different level of abstraction that can be done. We can work at the IP level, at leaf level, what we call it leaf level. We can also work at subsystem level, top level, chiplet level. So we can work at any level that the team would like to focus on.
How much of this is standard based? Has IP-XACT and some of the other protocols, have they all kept up with what needs to be done in these designs, or is there still a lot of, we need to manually tinker with this?
If there is some custom flows that you want to put in place or custom feature that you want to put in place, IP-XACT is good for that because it's an XML format. So you can you can add attributes, you can add metadata that you can retrieve at the end and script based on the values of this information.
This is still complicated stuff. What sort of problems do engineers run into working with this? You've done a good job in terms of identifying a lot of the problems, but it's still never that simple, right?
Exactly, as you need sometimes to address different needs from the team, so you have to build sometimes the design by layer to address the power, to address the GFX needs. So these still need to be defined with the architecture team and put the strategy on place to address these pains.
Basically, it's got to be integrated with a much larger flow of what's going on here, right?
Yeah, that's true. And you need also a connectivity, an assembly solution that will help you to put all these IP all together, elaborate your system and validate it at the end.
Do engineers need to keep learning stuff as they go along, or is it still pretty much the same tool that they've been working with, only now it can do more?
This tool doesn't require an expertise in IP-XACT. For example, we have everything handled. We have lots of API that will help you to do the packaging, and even with the rest of the Magellan platform, do the integration and manage your register very easily, very simply. It's seamless, actually. And also, with the new IP-XACT version that we are supporting with this new product, it's very easier to address the system Verilog specific feature like the structure, the system Verilog interfaces. All these are now natively supported by the new version of the standard, and it will help to have to streamline the integration process.
How has IP-XACT evolved to make all this work?
Actually, the new version of IP-XACT 2022 is addressing more and more limitations that have been seen in the previous version of the standard. So we have a better definition of the expression using a system Verilog. In IP-XACT 2009, we are using XPath, which was not very user-friendly. We have the management of the catalog that are now handled natively with this new version. We have a better support of system Verilog with all the new the struct, the system Verilog interfaces. We have also the specific elements like the type definition that could be used to define and describe the memory map, having this kind of template that could be used from one project to another. There is actually more and more feature, the power domain that could be also handled, the analog and mixed signal properties. So yeah, it's a more complete, more straightforward standard that help to address the complexity of the new SoCs.
And this is no longer just a planar SoC that we're dealing with for the most part with a lot of these complex IPs. Now what it is a complex assembly, multi-die assembly. You've got advanced packaging of different types, and a lot of these are customized too, right?
Yes, exactly. So, for the case, for example, for the multi-die, you can define that with a disaggregation of your SoC, having assembling all the elements together, and would like to partition based on a specific constraint that you defined through the architecture, or you can have different chiplet that you want to aggregate all together and define your new system. So the IP-XACT, you can, as I explained earlier, you can define different level of abstraction, and from the moment you define this description of the interconnection that you want to put in place between the different chiplet, you can put all this together, validate your system map, and validate your system.
Does this change at all as we move from 2.5D to full 3D IC?
Not really, because these interchip can be modelized and can be described in a higher level of abstraction using IP-XACT, so there is no problem with that.
But you may have multiple NOCs in one of these as well too, right? It may not just be one, because you've got GALs, globally asynchronous, locally synchronous. You may have to move data in different directions.
Right, that's true. You can have multi-NOC, you can have a composition of NOCs. So these are problems that we are already handled with our solution. So you can still connect these NOCs all together and create very easily your system high level.
Do those NOCs have to be coherent, or can they operate independently?
There is no limitation regarding the intent that is behind this specific IP. So when you package your IP, as all the information is here to define the boundary of your IP, or what is needed to have a seamless integration at the end, the real behavior inside this is actually hidden. So this complexity with coherent, no coherent, is hidden with the packaging of the IP.
When you think about an SoC, and actually even a advanced package that's multi-die, a lot of these, typically the IP that they use in there was pretty much developed in-house, put together in-house. That's changing, right? It's really what you want to be able to do is reuse this stuff, and you can't necessarily do that the way they've been doing it in the past.
Exactly. Yes, let me show you. Let me explain how the packaging solution helps the engineer with addressing the challenges and the pains that they see on HM when they are integrating the SoCs. So the packaging solution offer a single source of truth, a specification to define the boundary of the IP, the structure of the IP, the memory map, having this in a single description that could be used for multiple usage by the different team, generating automatically all the collaterals needed on their task. Second thing is having these automation in place will help to shorten the process, so they will be able to have on time tip out, successful tip out, because with this solution also integrates built-in checkers regarding the compliance to the standards, having all these check for the IP-XACT grammar, semantic, and also Accelera guidelines help you to have a valid and clear and data that is ready to be used at the design level. So improving at the same time the quality of the generated design, shortening the timeline. This actually will give more time to the team to have a faster innovation. So it will leverage their technical expertise, giving them more time to focus on their core business and dream of other things.
And one of the things that you're wrestling with right now is these are AI chips to a large extent. Almost everything's AI these days, or has some element of AI in it. And the AI models and LLMs are changing so fast that you really need to be able to take advantage of that and be able to build a system that is incredibly energy efficient as well as very fast. And the way that you're doing that is by saying, okay, what do we need to develop that's new and what do we need to reuse?
Exactly. With this kind of solution, you will focus on the core problem, on the specific problem. Don't need to spend more time on the integration itself or on the validation, because these have been handled in the beginning when you package the IP.
Insaf Meliane, thanks for a great explanation.
Thank you for having me.